Hello everybody, I hope you all have seen this equation. This is called nuclear fusion reaction, where two lighter particles combine or fuse and create a heavier stable particle. And one of the elementary reaction that you have seen is the fusion of a deuterium and a tritium, and they produce helium-4 and a neutron, as you can see on the screen, and energy or photon. But this is not what reaction happens inside the sun, inside the core of the sun. The reaction that happens inside the sun is called Proton Proton cycle, where we have three stages to produce the helium-4, and here you have a really fascinating concept about beta decay and radiative capture, and then you have ultimately the fusion. So let's see it from an advanced lens of particle physics or advanced nuclear physics. As I told, the first stage is beta plus decay or decay of a positron, where a proton is converted into a neutron, and that is why when you see these two protons initially fuse together and create a deuterium, which consists of proton and neutron, and this is possible due to the beta plus decay. So you see how sufficient is the beta plus decay. Without this process, no life on Earth would ever exist, because the fusion won't occur inside the sun. However, you can also see this interaction using quark's constituents and Feynman diagram as follows. The second stage is radiative capture, where the parental nucleus absorbs a proton or neutron. In our case here it absorbs a proton and quickly releases a high energy gamma ray. Thus we get a daughter nucleus or a tritium. Now come to the last part, that is fusion of two tritium. But this process is not as easy as you can see on the screen, that is two tritium fused and create helium-4 and emits two proton. Rather, what really happens that two tritium combines together and forms a resonance particle, a resonance nuclei, that is beryllium-6, but it is highly unstable, so it quickly decays to helium-4 and emits two proton, which you initially saw on the diagram of proton-proton cycle. And this is all about how sun fuse hydrogen together to form helium, and we get energy and life is possible on Earth. A last bonus information, in this proton-proton cycle we talked about resonance, but you might wonder, what is a resonance? A resonance is a short-lived intermediate real particle, unlike virtual particle, for instance WC Boson, which is a force mediator for beta decay process. And this resonance have a very short lifetime, that is, it appears as an intermediate state and quickly decays into other particle. For instance, in our case we took example of beryllium-6, which quickly decays to helium-4 and to proton. There are many famous resonance exist. For instance, we have delta resonance, and more famous resonance is Higgs boson, which is responsible for providing mass of an object by Higgs mechanism. And in our next video we will talk about Higgs boson. To understand this, you really need to have a strong passion for particle physics and nuclear physics, symmetry breaking, and all these crazy things. So that's all for today, and we will see you on the next video. Until now, take care and keep studying.